So we're going to solve these quadratic equations using the quadratic formula. To emphasize the benefits of the quadratic formula is you get an exact answer. You don't have to settle for an estimate, and it always works, unlike factoring. So let's take a look at this first problem here. We want to identify the a, the b, and the c, ax squared plus bx plus c. So in this one here, my a is 8, my b is -7, and my c is 1. I've written my formula right here. And so we're going to substitute these values into our formula. If you use really good notation, remember you want to put a set of parentheses every place there was a variable. So the B is a set of parentheses, the A's are sets of parentheses, and the C is a set of parentheses. Then we're going to insert those numbers. If you have a decent calculator, if you use good notation like this, you could just enter it straight into your calculator like this. Okay, but I'm going to grab my B value. So negative B, -7, plus or minus the square root of b squared, -7 squared, minus 4a, which is 8, c, which is 1, all over 2a. Okay, so there's my a. Then you might want to do a little scratch work off to the side to just find the answer to what's underneath your square root vocabulary. That's called your radicand. So I'm grabbing the -7 squared minus 4 AC. In a quadratic, it's also called your discriminant. So sometimes you'll refer to this answer as your discriminant. All right, so exponents, -7 squared is 49. And then multiplication, -4 multiplied by 8 multiplied by 1 is -32. 49 minus 32 is 17. So the answer to the discriminant part underneath the root is 17. -7, so 7 and 2 times 8 is 16. And this simply means we have two separate answers. We have both 7 plus the square root of 17 over 16 and 7 minus the square root of 17 over 16. A little tiny extra information, if you were to add 7 and square root of 17, get an answer, and then divide by 16, that is the location of the x-intercept. And 7 minus the square root of 17, get an answer, divide by 16, that is the location of the other x-intercept if we were to graph y equals 8x squared minus 7x plus 1. Okay, so here's one more example. Just simplifying the root is a little more exciting here. So identifying A, B, and C. So my A is 3, my B is 6, and my C is -1. Then I jot down my formula, parentheses every place we have a variable, then let's substitute that in. -b, so -6, plus or minus the square root of b squared, 6 squared, minus 4a, c, all over 2a. Little bit of simplifying there. Simplifying the discriminant, 6 times 6 is 36, -4 times 3 times -1 is plus 12. So if I take 36 plus 12, I get 48. Up front here I have a -6. And then all over 2 times 3, so all over 6. Now this time I've got a little bit of simplifying to do because that square root could be simplified. Remember, you want to break that up into a product of primes. 6 times 8 is 48. The 6 is 2 times 3, and the 8 is 2 times 2 times 2. So if you expand that 48 to become 2 times 2 times 2 times 2 times 3, when you go to simplify, 2 of a kind, you take 1 out. So I have a pair of 2s, so I'm going to take a 2 out, another pair of 2s, so take another 2 out, and that 3 is trapped inside. Okay, so taking out a 2 and another 2 is 2 times 2 out front, which is 4. The 3 is trapped inside, 3. Okay, now finally, when you go to simplify a fraction, you can't cancel over addition and subtraction. You can only cancel in a fraction when you have multiplication. So I need to factor this numerator here, and 6 and 4 square root of 3 both have a 2 in common. So I'm going to take a 2 out, and if I take a 2 out of -6, that gives me -3. -6 divided by 2 is -3. Then if I take a 2 out of 4 root 3, that's going to give me 2 root 3. All right, you could redistribute to verify that. 2 times -3 is -6. 2 times 2 root 3 is 4 root 3 over 6. And now that I have multiplication in the numerator, I can cancel. So this 2 cancels with this 6. And then that is going to become 3, right? 2 fits into 2 once. 2 fits into 6 3 times. So I end up with -3 plus or minus 2 root 3 over 3.
Please excuse the interruption.